Welcome to springlib.
For this problem, we're going to be doing implicit differentiation, which is incredibly useful when we have x's and y's in an equation, or we have two functions being set equal to each other. So how it works is we're going to take the derivative of both sides. We have the inverse tangent right here. This is the inverse tangent of x squared y equal to x plus xy squared. I will take the derivative of both sides. When we take the derivative of the left side, we're going to have to use the chain rule. We know that what we'll get is going to end up being, since the derivative of the inverse tangent is 1 over 1 plus u squared, for example, what we'll end up getting is, in this case, 1 over 1 plus x squared y. But then we have to do the chain rule. So that's going to be times, and then everything in here. So it's going to be x squared. This will be the product rule right here. So x squared times y prime plus y times 2x. That's chain rule right there. And then we take the derivative of this. So we'll get 1 because the derivative of x is just 1. So we'll have 1 plus, and then we'll have to do chain rule. So it'll be x times 2y plus y squared plus 2y times y prime plus y squared. So that's what we end up getting here as a result. We can multiply everything through right here. So what we end up having as a result is going to be x squared over this portion down here. And then that will be, in this case, since we had to square this portion, since we have to do u squared, this was squared right here. So what this is actually going to be is x to the 4th y squared. And then we'll have minus 2xy. And then another thing we have to keep in mind is that in having the minus 2xy, this is going to be all times dy dx, which we can write as y prime. That will be equal to 1 plus y squared minus, and then 2xy over 1 plus x to the 4th y squared. So the reason we get this is because we know that we can combine these, and when we have the negative 2xy, this is coming from our distribution. Right here, the y times 2x is 2xy, and we know that it will end up becoming minus that value when we subtract it, because we have 2xy here as well. Then what we can do to simplify things further is we're going to divide both sides by this portion right here. So what we'll end up getting as a result when we divide all this is we're going to have that y prime is equal to 1 plus x to the 4th y squared plus y squared plus x to the 4th y to the 4th minus 2xy. And that is all going to be divided by x squared minus 2xy minus 2x to the 5th y cubed. And that will be our final answer for y prime.